Okay, so I'm going to start off by asking a question, right? Real quick. How many of you here can tell me, or how many of you here actually know what this is? By show of hands, just by show of hands. A decent number of people. Well, I'm sorry to say, but scientists and physicians aren't eligible for this question. But it's okay. Now, the people who did not raise their hands, does somebody want to quickly shout out and take a guess as to what this is? Pencil. Oof. It's pretty close. Well, it's actually also known as a pen. And this is actually an insulin injection that some individuals have to take multiple times every single day for the rest of their lives. And in the next few minutes, I'm going to tell you why. You see, whenever we eat something, right, whenever we eat starchy foods or foods that contain carbohydrates, what happens is this food goes into the body, it gets digested, and eventually it gets converted into a type of sugar. This sugar is what we call as glucose. Now, what happens with this glucose or sugar is that this flows throughout the body via the blood. And this is what we usually refer to as blood sugar or blood glucose. But what is the purpose of the sugar in the blood? You see, whenever we do some activities, right, whether it's me speaking to you right now or it's you listening to me, it all requires energy, right? Even if you're sitting there and thinking, well, this beautiful Montreal weather today, along with the lunch that you just had, is making you feel sleepy, which it really does make me. The thinking that you're doing is also actually using energy. And this energy comes from that very sugar that flows in your blood. Now, naturally, this sugar is converted into energy using insulin. So in the body, naturally, we have these cells called the insulin-producing beta cells that produce insulin as soon as they get an alert, right? So as soon as you start munching on something or you eat something, the brain sends a message to your pancreatic insulin-producing beta cells, and they produce insulin. In fact, let me also tell you this. It's not just you munching on the food. Even if you look at some really yummy food, and by the way, vegetables don't do the trick here, it starts to send a signal to your pancreatic beta cells, your insulin-producing beta cells, and they start releasing insulin because that's the factory of insulin. Now, this insulin is key because it literally works like a key, and it helps convert this glucose in the blood into a form of energy that we can use. Now, what happens with individuals who have to take these injections? You see, when you and me were so beautifully crafted inside the wombs of our mother, it's perfection at its finest, right? The immune system, which is the defense mechanism of the body, or for the sake of the analogy, I'm going to call them the police here, they took a vow and they swore to protect us from danger, right? So whilst we're developing in the mother's body, the baby, the immune system gets to know who are the civilians, and the immune system protects them in the future. Unfortunately, for some individuals, at some point in the future, the immune system betrays the insulin-producing beta cells, and it mercilessly murders them, right? Cold-blooded murder. All the promises broken. And unfortunately, the only way that these individuals can then have insulin, because their cells, they don't have the cells anymore, they're not producing insulin, so the only way that they can convert the sugar in their blood into energy is by using these insulin injections or insulin pumps. But that is not where the story ends. It gets even more mysterious now because, as you know, the innocent civilian, the beta cells, got murdered by the police. But recently, detectives, which in this context are the scientists, have discovered that the beta cells themselves, the insulin-producing beta cells, are responsible for their own death. They have what we call the suicidal tendencies, right? They have their own death wish. And it's funny because these victims that get murdered are committing suicide by telling the murderer to commit their murder, right? Complicated, mysterious, and very fascinating. And that is what I work on in the lab. I work and I'm trying to find out why these beta cells have these suicidal tendencies and how they're trying to kill themselves. And that is the treatment part, right? So eventually in the future, hopefully we find something that can help us avoid the beta cells from trying to commit suicide. And when we go to the cure part of the disease, we come to where you can generate beta cells in the lab, and then you can transplant these cells in the human, and they can produce insulin. These are all very early phases trials that are going on, and hopefully in the future, we can have both a treatment and a cure for type 1 diabetes. And before I very quickly end, does somebody want to quickly take a guess if there's any other prop on the stage other than the insulin pen? No? Well, let me tell you, I am a prop myself, because all of the mystery that I just told you about was something that took place in my very own body about 15 years ago, and this little guy has been my partner ever since. Thank you very much.
In English is better for you.
Yep.
So I just want, you were talking about type 2 diabetes, but could this be also applied, you were referring to type 1. Type 2, could this be applied to type 2, the one that you acquire with unhealthy living or later in life? Could this be applied?
Very interesting question. Thank you for the question. Well, there's an inherent difference between type 1 and type 2 diabetes, right? So type 1 diabetes, like I said, is where the immune system attacks your insulin-producing cells and they die. So your body no more has insulin, which is why you have to take insulin through an injection. In case of type 2 diabetes, that is not the case. Your insulin-producing cells are completely fine. They're releasing the insulin. In fact, they're releasing more insulin. But because of a person's lifestyle or their weight, what happens is this insulin that is being produced by the body becomes resistant, right? The cells become resistant to this insulin, as a result of which the sugar is not being converted into energy. So the difference here is that in type 1 diabetes, we don't have the cells, we don't have the insulin, whereas in type 2 diabetes, we do have the cells, we do have the insulin. It's just that the body is resistant, which is why we can take tablets, medications, exercise, and that can reduce the resistance and the insulin can do its job.
Okay. Question dans la salle, oui, derrière.
Hey, thanks for a great talk. I was wondering if the treatment plan with the injections has to be adjusted as time passes. So as you get older, do you need to adjust the quantities or the frequency or the type of insulin you inject?
Well, that's an interesting question because it's not just when you get older. In fact, you have to adjust and manage your insulin doses every single day, right? Because, like I said, insulin resistance, which is a factor in type 2 diabetes, is also a factor in type 1 diabetes, right? And naturally, your body knows how much insulin is needed for the amount of glucose. But when your body is not doing that, and when you're going through, say, stress, or if the weather, like I was saying, is a little different, or if you did not have a good night's sleep, or if you had a fight with someone you love, a lot of these things, a lot of these factors can actually affect how the insulin is working in your body. And unfortunately, as a reason of that, when you manage your blood glucose using insulin injections, it is not stable at all. You have to change your dose almost every single day. And eventually, through experience and practice, you get to know, okay, if I'm eating this kind of food, I need to take this much insulin. If I'm working out this much insulin. If I'm stressed, this much insulin. But it's all on the spot, impromptu.
Oui, question?
Whenever we think about diabetes, the first thing that comes to our mind is, okay, what I should eat, right? And since you have been living with this type 1 diabetes for the last 15 years, and most probably you live with it in your whole life as well, what should be the diet pattern for that? Should we really concern about the diet, or what can we eat? Like, is the general public, what can we eat?
Thank you for the question. Well, see, here's the thing again. Individuals with type 1 diabetes can actually eat everything, right? They can eat anything they want. It's just that if they're eating something sweet, they're having a soda, they're having a bar of chocolate, they just have to take a little bit extra insulin, right? Because their body don't have it, so they inject an extra amount of insulin. But then that being said, type 1 individuals can have whatever food they want. I think it is just as important for them as it is for everybody else, whether or not they have type 1 diabetes, that they follow a good diet in which they take the right amount of proteins or the right amount of carbs, and they just live a healthy life, So type 1 diabetics, in my opinion, don't really have a specific diet, but it's best that they take less carbs and they manage their doses accordingly.
Question dans la salle, oui. Question ici d'une juge devant aussi. Ouais. Le micro s'en vient. Il est rendu où? OK, c'est bon.
Should I just ask my question?
Oui.
Okay, so people with type 1 diabetes, their bodies have killed their own beta cells. But that doesn't happen very often. For the majority of people, we don't have that happen. So why does that occur? And is there a way to stop it from happening in the first place?
Well, yes. So that is what I work on in the lab. We don't really know what is happening that is leading to these beta cells inviting the immune system to come and kill them, right? We don't really know what's happening, which is why a lot of groups across the world are trying to study what actually causes it. And what we can do these days is that children, after they're born, they can be screened. They can be screened for their genes. So we know certain genes that if people have them, they are susceptible to getting type 1 diabetes. And if we get to know that, okay, these children are susceptible to getting type 1 diabetes, and we someday discover what is causing it, then we can give them the medications to try and prevent that from happening.